Hi there, during this session I'm going to be talking about power, specifically power in relationship to electrical energy. So first of all, just think back to what you already know. What is power? And maybe what is a power rating? Okay. So getting those questions developed in your head. So first of all, you probably should already know that power is the amount of energy transferred per unit time. Okay. Now, a power rating may be something you're less familiar with. A power rating is something which may appear on an appliance, and all it really is saying exactly the same thing. It's telling you how much energy is transferred every second in a certain appliance, something you may find around the house. And the rate of energy is changed from one to another, so it's energy change. Still, we're talking about something which is measured in watts, which is equal to 1 joule per second, which is the units for power. So, energy in joules, power in watts, time in seconds. With this understanding, you can work out and do some basic calculations. So let's get ourselves going by going back and thinking about some basic energy and power calculations. Here's 5 questions. I'm going to give you a few moments, so press pause now. That should give you enough time to have completed those questions. Let's see how you've done. 60 watts. What's the power of the electrical fire that transfers 10,000 joules in 5 seconds? 2,000 watts. Ferran runs up the stairs in 5 seconds if he transfers 1 million joules of energy in this time. What is his power rating? There we go. And there we go. If you've got any problems with these, you need to think back and speak to your teacher, okay, or look back and review how you got those numbers. Okay, next step, let's think about this in relationship to electricity. Okay. Electrical energy is calculated through current times time times voltage, which is ITV. Now, we know that power is energy divided by energy transferred divided by time. So power equals energy divided by time, so that means power is current times voltage. That's how we calculate the power of an electrical device, by measuring the current travelling through and the voltage across the component, with voltage measured in volts, current measured in amps, and power measured in watts or joules per second. So using that simple formula, here's a question for you. If you have a filament bulb and it has a potential difference of 200 volts across it and a current of 0.2 amps running through it, at what power is that bulb operating at? Stop for a moment to do the calculation. And now the answer to that is 40 watts. So this would be a 40 watt light bulb. One step further now, I want to think about power and power use in your home, okay? So in your home there's likely to be an electricity meter somewhere. It records how much energy or electricity is used in something called units, and we'll talk about what a unit is in a moment. So from the units you can use, from the units on your electricity bill, the amount of money you pay is calculated. So look at here. If we look at the meter, it's initially at this number here. Jot that down, I remember that. And then a little while later, it's changed to this number. So we have to calculate the change in units to work out how many units have been used. In this case, the answer should be 26. So for each unit you have consumed, you have to pay a certain amount of money. So the cost of electricity is just the number of units multiplied by the cost per unit, which is easy enough. And that means that if you used up 10 units at a price of 9 pence per unit, that would be 90 pence worth of cost. Now, I talk about this stuff and it's fairly straightforward. The thing that gets people, and this is maybe more of a future life skill, is the idea of what a unit actually is. Because you're thinking about buying units of energy. So joules would be a sensible system. But unfortunately, electrical firms around the world don't use joules. Instead, they use something which is known as a kilowatt hour. So energy is a multiplication of power times time. And what they've done is 1 unit of electricity, a measurement of energy, is 1 kilowatt multiplied by 1 hour. So think about this. How many units of electricity in 17.6 kilowatt hours? 17.6 units. If we have 45.2 kilowatt hours of energy, the electricity costs 10 pence per unit. How much does it cost to use the kettle? So we said that the amount of energy used by a kettle is 45.2 kilowatt hours. Number of units is 45.2. This would cost 452 pence or 4.52 pounds. Another type of question. Power is 3 kilowatt hours for 4 hours worth of use. That means that 12 units are used in total. 12 times 8 is 96 pence. So there's some examples of calculations you may have to do in the future relating to power and how much you use and how much you have to pay for it.